This is my work for Lab 8, starting with the pre-lab calculations. It's essentially a voltage divider in which you find V out is equal to 1 plus R2 over R1 V in. Then from there, I wrote some Arduino code that does a serial begin, sets pin modes, and reads those and prints them out segmented by tabs every 50 milliseconds. Then in processing, I made some changes to the Lab 5 code, including changing the XYZ raw length, as well as adding a third A3, and then printing it with the corresponding colors. Now for this, I expected them to all have the same values, and I get something very similar to that. You see they all change very closely together. Then below 2 volts, it looks like V in from the potentiometer varies, whereas the V out and V minus stay stagnant at 2 volts. I believe that's due to power requirements for the op amp itself regarding power from the Arduino. For exercise 3, this here is my circuit. It's a bit messy, but it gets the job done. And as you see here, I can take you to the processing code first. Essentially, I just added a 4th variable, pulling off XYZ raw, you can see that. Printed it with a new color, added a new label. Similar process in Arduino, simply just added a new variable on that 4th port, and added it to the output string. As you can see here, if I move the potentiometer, my yellow voltage stays at about 2.5. The green and white change pretty similarly, and the blue will jump from 2 set voltages. For exercise 4, here's my derivation of the output based on the transfer function of the circuit, and then replacing the capacitor, capacitor as a complex impedance, and then subbing that in. Over on Arduino and processing, I've made very few changes for this section, and then as you can see here, as I move the potentiometer, there's an integrating force from the op amp. You can see it's close to 2.5 volts. It moves very slowly due to the capacitor, and I believe it functions as it should.